Hello, everyone who's joining us at the moment. We'll give it a couple of minutes just to let people join, and then we'll get stuck in. Okay. People are still coming in, so as I said, we'll give it a couple of minutes, and then we'll get started. Right, okay then, I think we'll get started. So hello and welcome to everyone joining us for our forum on Vision in Action today. I'd like to thank our panellists for agreeing to join us and talk about this topic. Vision is really interesting and one where we find companies in the same space having a very wide range of products and specialisms. We've already been talking about it in prep before we actually started the forum. So expect a wide variety of opinions today. Just quickly, a little about the format. We have a series of questions for each of the panelists to answer. This should last around 30 minutes. We will then answer as many questions as we can from the audience. So if you have a question, please use the Q&A function at the bottom of the screen, and we'll manage those questions towards the end. And I hope we can get as many answered as possible, but we will limit the time to 45 minutes so you can all get back on again with your day. For further information on this topic and anything else you want to ask, please join us at Vision UK alongside Automation UK exhibition on the 7th and 8th of May at the CBS Arena in Coventry. So to save you having to listen to me any longer, let's get to the questions. To all our panelists, could you please give a quick brief introduction to yourselves and then answer this first question? So in my mind, AI is a very important part of vision applications. Can you expand on AI, how AI is changing the vision industry and its importance, and possibly how it's already changed it? So that's to Scott, please, from Laser Components.
Hey, good morning, good morning. Wasn't sure what time it was there. My name's Scott. I'm from Laser Components UK. So we're a German manufacturer, and then we've got a UK subsidiary. So my role is business development, and we cover a range of products. There's clues in the name with Laser Components, but we provide like emitters, detectors, laser sources, and we also work with a range of different suppliers to offer other systems and more customized like solutions for people. So to answer the question, I think we're seeing a lot of like uses of AI in many different industries where previously there's a bit of a bottleneck for getting processes done, or getting like it's taking a long time to actually measure anything. So you see with AI, it's increasing the throughput of different systems, and it's quite exciting to see how this is getting adapted into many different industries, including like automation and machine vision. Yeah.
Okay, thank you. It's interesting. So Stuart from SICK.
Hi, my name's Stuart. I'm a machine vision sales specialist at SICK in the UK. SICK is a worldwide industrial automation company. From the name, it's not quite so easy to understand that, but we are worldwide. In terms of how AI is changing, it certainly has a part to play in the vision market. and there's a lot of misconception on what AI can do to a vision application, and it makes it vision simpler. AI can be a very powerful tool, but so are other rule-based tools. The AI with use of a golden template for anomaly detection and classification is one of the main areas that it's developing into, but this is not the only way to do it. So, from an AI point of view, it's being touted as being the future. I think it will be a very strong part of the future, but at the moment it's still developing on how it actually works in a real world application.
Yeah, no, thank you so much. Simon from Multipix.
Hello, everybody. Yeah, my name's Simon Hickman from Multipix Imaging. We are a vision specialist, stroke distributor of everything you need to put together a machine vision system. We don't actually put systems, integrate systems. We sell to integrators and OEM customers that want to do vision projects, but there's a very high level of support and understanding of all those products that we have, and we've been in this business for well over 25 years, so there's quite a deep knowledge there. So I'm also at the moment the chairman of the UK IVA as of the beginning of the year. So I'm sure you'll see me about at the show that Laurie's mentioned. And that's really the whole crux of this webinar, really, to encourage people to come along. So okay, that's enough about me. So the AI question, I've got to say, I absolutely hate the expression AI. Artificial intelligence, there's not much intelligent about it. It's what you put in that makes it. Don't get me wrong, it's a very, very powerful. What we do is we refer to AI as deep learning. So deep learning is really a neural network which has been around for decades, but with the processing power that's now available to allow you to put thousands, tens of thousands of examples of what you're looking for in your data set for your neural network. So it makes it incredibly powerful. Things that would have taken weeks and weeks to train, they still take a while to train, but you can actually include an incredible amount of detail in those classifiers. Now, what Stuart said was actually right, in my opinion, in the fact that it means that it's not good for everything. This is the problem. Everybody thinks AI / deep learning is the answer to everything, and it certainly isn't the answer to everything. It's incredibly good for classifying things that are not finite. In other words, organic products that vary slightly every time, or things that are deformable slightly. It's therefore very difficult to define that kind of object easily, because you can't use a CAD model, because of course every single one's slightly different and so on. So it means that using these huge data sets, and I think Stuart already mentioned anomaly detection as one sort of thing where you'd train everything that was good. There's no bads, there's only goods, and you basically train everything that you can take as a good sample. So if something's deformable, you need all those permutations in your data set, which makes it incredibly powerful. You would never been able to do that before. So it's actually opening up lots of markets for us. It's really quite an exciting thing. It's just misused a lot, and everybody thinks it's the answer to everything. Okay.
And although it's my question, I have to admit I'm in complete agreement with you on the use of the term AI. I think it's all the elements underneath AI that are really, really important, and we don't talk about it enough. But it's like talking about robots in automation. Everyone understands what a robot is. Everyone sort of has an idea of what AI is. So thank you for that, Simon. And then finally, Jack from TPL Vision.
Hi, so I'm Jack McKinley. I'm the head of development for TPL Vision. TPL Vision's a lighting manufacturer. We specialize in lighting for the machine vision market. And I manage the development team up here in Scotland, and we produce our products in France. And we're part of the Wengler Group, which is a large machine vision and sensor company based out in Germany. What I would say about AI, I really would reflect what Stuart and Simon have said. They've sort of taken what I was planning to say. And I would say that, yeah, certainly rule-based systems, which is the sort of more traditional machine vision systems, they really have their place. And I don't think it's spoken about enough. I would say that AI-based applications is really, for deep learning in particular, it's really an extension of what's possible with machine vision. So it opens up new markets. And I would say that that's the most positive way to look at it. Really solving applications that weren't possible before. I mean, for us, from a lighting standpoint, it's good because we can think about new application areas. So say woven textiles is something that was always really difficult in the past with rule-based systems because of an unknown type of defect. Deep learning, of course, can help solve that. But yeah, there's challenges, and I think the way it's spoken about isn't really reflective of how it actually is in practice. And there is a lot, of course, with edge learning AI applications, which are the more entry-level stuff, and that is, of course, is a factor to it, making the machine vision systems simpler. But I would say that the real growth area in machine vision is with deep learning.
Cool. Thank you for that. And Jack, you can go first next. Okay. So the next question is, in addition to AI, what is the next big thing that you see coming to the vision industry at the moment? So yeah, Jack, over to you.
Yeah, so I mean, we of course, I mentioned that we're a lighting company. So really for us, I'll talk a bit specifically about where the lighting trends are going, and what we see. Really, there's a lot of development in new LED technology that is kind of aligned with the sensor technology. So SWIR is still very much an open topic. We see the Sony coming out with new types of sensors and the cost of these sensors going down. So I think that this will continually be a trend that we will see over the next few years. Additionally, I think it's reflective of the sort of past few years, but the automotive market is really going down in terms of machine vision use, or it's maybe steady. And the newer markets would be things like fast-moving consumer goods and logistics as being the higher growth areas. So that's really from our know-how about lighting, and that's what we see in the market going forward in the next few years.
All right, thanks, Jack. Simon, what are you seeing?
Well, there's a few things, but I would say that, I mean, certainly AI should have popped up over the last handful of years. It's still not quite where it is, but in the last year, it's taken off massively. So the next thing, we've been talking about embedded technology for a very long time also, and of course, it's taken a huge amount of time for that to catch up to a point where there's really stuff available that's usable without starting reinventing the wheel, so to speak. And that has taken a step change fairly recently. So we now have some embedded products that really they're only, when you think about embedded, it's about volume. So if you're into a big application, it's worth spending the time to reduce the unit cost. When people think embedded, they just think board level cameras, but that's not just it. It's more than that. It's about the interface. It's about simplifying everything. So you basically cut everything down to the bone from a unit price point of view, but you don't compromise on the performance. So that's one thing that's definitely coming. But going on to the application areas, I totally agree with Jack. So, I think what we are seeing and what we've seen over the last at least 5 years, if not more, it's going more and more in that direction, is our technology being used so-called out of the factory. Okay, so non-industrial applications. And this is where, and that's what's driving the market actually, and not least the lighting market. So, the LED technology, a lot of it's been driven by automotive. And it's funny that Jack mentioned both of those, because the LED market for headlight technology and so on, that's driven LED technology on massively. So the great news about having lots of extra light is that you've got other options for your lensing and your camera sensitivity, and it kind of goes back down the chain, and it opens up this kind of embedded market a bit more because some of that is less expensive and so on, and therefore maybe not quite so sensitive as a more expensive camera, etc. So those areas really embedded, other markets coming in. There's nothing that jumps out at you. When USB 3 came out, that was a big thing for us because it had never been used before in vision. That's kind of been and gone. Everybody uses that now, of course, and so therefore looking for the next trend, it's quite difficult to predict it's going to be big, but embedded is definitely coming big time.
Cool. No, thank you, Simon. Stuart, what do you think?
Yeah, don't disagree with either of the two previous responses. I think from a SICK point of view, what we see is the sort of, not the simplification, but the ease of integration of machine vision technology and machine vision algorithms. So basically what we would refer to as a low-code image processing software, so that it makes the user experience, almost going through like an embedded process, but actually making the end user experience simplified and presenting to them powerful machine vision tools in a way that they can actually visualize and use them. So it even covers AI along with 2D and even 3D technologies. So, I think that, going forward, taking the stigma out of needing to be a C++ programmer or a C# programmer, and being able to deploy automated applications in industrial automation, but also, as Simon said, outside of it, into logistics, into other areas where the technology is there to be used. It's just the barrier beforehand has been quite steep to understand how to implement it. So that's, SICK Nova software is a very good way of showing across platform how a singular concept can be deployed in multiple different ways.
Cool. No, thank you. And then Scott.
Yeah, I think what's interesting is probably you'll see that like more combination of different existing technologies, particularly for things with like robotics. We provide like light sources, so we get quite a lot. Recently we've got quite a lot of inquiries where we're contacted by people that have never used laser sources before, but they want to implement it into an existing manufacturing setup. So for stuff like cutting wood or cutting polymers, and they tend to not have very much experience with lasers before. So I think I remember when quantum computing sort of was being talked about more over the last few years. There was people who had expertise in like industrial freezers and fridges because of cryogenics, and then that technology was then implemented into like quantum computing systems. So I think you'll see, as there's more demands on throughput and more demands on manufacturing systems, there'll be more implemented technology from other areas and cross technologies.
Yeah, okay, thank you. So what do you find are your sort of regular biggest challenges that you face in vision to integrating systems into manufacturers and automation? And we're going to go straight to Stuart for that one.
I think the main word there you use is integration. It's actually making sure that the vision element is providing you with the information that you want, and that is actually linking into the rest of the automation production line, however it works. So the number of people that can actually say, I can do a demo of a machine vision camera process, etc., on a desktop, that's brilliant. It's a great sales tool, but actually it's how do you get that into your factory? How do you get it working reliably? How do you make sure that the process before and the process after are maintained and linked into? Vision is a great generator of data. You're taking a picture of every item that goes through. So you've got a good reference image of what's going on, but how do you use that? How does that be used for traceability in the future, for quality control in the future, time of day checks, etc., etc. So I think the big word there is the integrating it all.
Yeah, no, thank you for that. I can see that is a definitely a challenge. So Simon, next, what do you think the challenges are?
Yeah, I think Stuart's really quite right about the biggest challenge is actually the person taking on too much, let's say, or oversimplifying what the problem is. That's the biggest challenge. So it means that what you get is you get a lot of users that think, I'll just use AI and it'll do everything for me. And it's the age-old thing of, rubbish in, rubbish out. It's still just as valid now as ever. And that means that if you have an image that's not a very good image, you are not going to get a very good result. No matter how much AI you think you're going to throw at it, it's about getting the fundamentals right. So it means the lighting, the lensing, the right camera, resolution-wise, etc. So a nice crisp image of exactly what you're looking at. But what you don't want is something that's a nice picture, as in a nice photograph. You want what we call an image that kind of accentuates what you're looking for and diminishes as much as you can what you're not interested in. Because the first thing you're going to do in the analysis is what we call segment the interesting bit to analyze it. So it's about being clever. What you don't want is an image that looks good to the human eye. If all you want to do is measure the position of an edge, really all you want to see is one line, which is the edge in the image. That would be the perfect image for the analysis you want to do. So I think to sort of sum up, what's the most difficult challenge is making sure the integration is right, i.e. the person that's taking the challenge on has got the experience or has got, you know, the resource to find out the right things to do the project properly. Because the worst scenario is somebody takes something on and it doesn't turn out very well, and it puts them off of vision. And you know, it's not really vision and everybody thinks, well, no, vision's not very good because it didn't work. When actually maybe it was those choices that were made about the vision components and what was used for the project that was maybe the thing that went wrong.
Yeah, no, thank you, Simon. Jack, what's your feelings?
Yeah, I totally agree with Simon again. You know, but I'm going to come with a bit more bias towards the lighting. I would say getting the fundamentals right is still a challenge, and yeah, well, especially if you look at the workflow for a normal rule-based system and the workflow of an AI-based deep learning setup, you have to start with the data set, and the data set in this case is images. So really getting the fundamentals right, making sure you see contrast in the right places, as Simon mentioned, getting an edge to look like an edge with 100% contrast is much better than a nice image of the part, so you can just see the edge on a sort of shadowy grayscale. So of course, yeah, I totally agree with what Simon said, and I had the same answer. Yeah, really, it still is, and even more so now there's a lot of startups in the AI space. They have amazing software, and they're really focusing hard on making sure their software is perfect, but the fundamentals are sort of the stage before that I would say are overlooked a bit.
Yeah, no, I understand that completely. Thank you. And then finally to you, Scott.
Yeah, I think most of the points have been covered there. Like I agree with, like, I echo what Jack was saying, like coming from like a lighting focus, that obviously if you can have the best AI algorithm in the world, but if your camera can't see what you're looking at, then it's not going to be able to tell you any valuable information.
Yeah.
So and echoes what Simon said, like rubbish in, rubbish out. But I think, just to go back to my other point on like the combination of different technologies, obviously as these systems get more complex, then there's more demand on the calibration of such systems, and it's quite difficult. Like, as I said, we've been contacted by people who have no previous experience using the technology they want to use. So I think having known industry partners that you can work with, who you can get consultations from, is very helpful for anyone that's looking for new technology standing into existing machine vision setups or implementing like AI into their systems as well. So you need to speak to someone who actually is going to be able to give you the advice to actually get it set up, so you can, I mean, you don't want to invest a whole lot of money into something that's going to optimize your process, and then you spend the majority of your time just trying to fix it. So
yeah, no, thank you. So that is now that's everybody, isn't it, on that question? Losing the plot slightly. So so we sort of know what your specialisms are, but could you sort of like, do you have a case study, preferably from the last 12 months, that really show the importance of your area within the industry? And we're going to go straight to Jack for that one, I believe.
Yeah, I mean, I don't have an exact case study. I do have one. I do. I've got one that I was going to present at this Ukiva show. I'm doing a talk there, and I can just discuss briefly about it. But it is actually around deep learning and really using lights, and it shows that really the outcome of having proper lighting versus sort of, and this is the example is looking at coffee beans and looking for bad coffee beans amongst a bunch of coffee beans. And with bad lighting versus good lighting, showing a sort of hypothetical situation of really the importance of lighting. And There's two factors. One's the efficiency, so the F1 score is significantly improved, and the other is that the number of training images to reach the same F1 score is massively reduced from 175 images down to 45. So I can share this all in person at the UKIVA show with a presentation showing some images and things like that. But yeah, that's what I would say. The lighting, getting the lighting right from the outset is just massively beneficial to not just AI stuff, but any machine vision application. But again, I'm a bit biased because I just focus on the lighting.
It is your specialism, so that's why we ask.
Yeah, that is my specialism.
I know everyone's got a slightly different approach into vision, which is why we're doing it, why we're asking these questions. So yeah, no, it's perfectly valid. So Simon, please, what do you think?
Yeah, I've got to say, I think we probably all have got similar views on it. I mean, you know, we as a case study, I mean, there's so many. I think that, you know, it's the difference between, let's go back to what Jack said. You know, the camera only sees light. Okay, so it either sees absence of light or light reflected in a certain way. So controlling that light is massively important. And what you don't want is that to vary. In a machine vision application, you want it to be absolutely constant. So you do other things apart from trying to get the light coming from the right direction, or, you know, angle wise, or doing something clever with the color of the light, for example, to actually enhance the contrast on certain areas. Because there's another thing, you know, light, red things reflect red light, blue reflects blue, and green reflects green, and it absorbs other colors to various amounts. So if you had, I don't know, red text on a white background, to get maximum contrast, red text on a black background, black absorbs everything, red reflects red very well. So basically, you get black on white if you had a red light and a monochrome camera. If you used a blue light, most of the blue light would be absorbed by the red ink on that red text on black background, and therefore you'd hardly see the text. So your contrast would be reduced. So that was a pretty poor example, but basically what I'm trying to say is you can enhance the contrast with different colored lights. And then of course, when you go back one stage from there, you get to the lensing. Now the lensing is equally important, because, you know, the what you see in terms of field of view, in terms of pure resolution, what's so-called MTF, modulation transfer function, you'll see an edge very crisply. If you've got a very high quality lens, it won't be quite so good with a lower quality lens. You can affect that in lots of different ways by changing the iris in the lens and all sorts of things. But, you know, there's other fundamental things, like things look different in different parts of the field of view, for example. So you may see the sides of objects if they're on the edge of the field of view, whereas if it's in the center, you only see the very top, the planar view. So if you were to try and find, let's do an example of, I don't know, a component on a PCB. So you've got a printed circuit board, you've got a component on there, like a capacitor, and then when it's in the center, you only see the very top of that capacitor. If it was towards the right-hand side or the left-hand side, you'd see part of the kind of side of it, depending on for perspective, as well as the top. So if you were trying to train an algorithm to find the capacitors on that board, your classifier would need to be able to handle the fact that they look different depending on where they are. So it means you'd have to use some kind of neural network to do that. So it kind of, the analysis side of it gets a little bit more complicated immediately, and what examples you've got to give. But if you used a lens, like a telecentric lens, a collimated lens, that actually gives you a planar view of straight down, no matter where it is in the field of view. Now, you know, you do have to make sure the lens does get more expensive and bigger, but it actually simplifies the application massively. So it means that you actually can look at one particular, you know, the top surface of the product without any different views of it and so on, and therefore simplifies it massively. So that's probably gives you a little flavor.
Cool, thank you. So Stuart.
What I would do say is SICK is well known in the logistics industry. So, you know, an application or a case study in this particular case. Logistics industry is tracking parcels through logistics warehouses. We all know of them. You know, quite often one delivers to most people's houses every day, I would have thought. But we've had an application recently which was deployed using time-of-flight cameras. So time-of-flight camera is a 3D camera that just basically sends pulse of lights out and measures how long it takes for that pulse of light to come back. Fact for you, light travels 30 centimeters in a nanosecond, so it gives you an idea of sort of how critical timing is in the camera for that. But this particular logistics company was trying to understand the volume of the carts that they fill packages in, and making sure that the transportation of these carts are optimized. And through using time-of-flight cameras to identify the 3D volume, they achieved a 5% cost saving in their transportation costs. Now, to a logistics company, 5% saving is a very, very, very attractive thing to do. So, using technology that's designed for machine vision, but used in a different application. I think we've discussed this before within this group about what was used in industrial automation in the past is being used into different applications, into different industry sectors. And I think this is a very good example of how 3D technology designed specifically for machine vision is being used to help logistics and the logistics industry.
No, thank you, Stuart. And then finally to Scott.
Yeah, so in terms of like case studies, so I think we have some like specific examples of like, but I think what's probably interesting for us, just to make people aware, we're largely a components manufacturer, but we do have, we're working with one customer we're working with at the moment, came to us and they wanted like a full solution where they had not a lot of experience using lasers and optics. So we work with a range of like industry partners where we can offer more plug and play solutions versus just providing the bare components. So I think the main reason why this company contacted us was they spoke to another company, and the response was basically that they didn't want the extra hassle of developing a system, so they just wanted to provide, here's a laser and figure it out. So as we've all mentioned, there's more and more demand for new technology and manufacturing setups and machine vision systems. So being able to speak to someone who can offer like a more complete solution versus just bare parts is definitely helpful. So that's something we can definitely do.
Thank you. So we're really doing well. We're really knocking on for time, actually. We've got a couple of questions from the audience, but there's just one last one that I'm going to jump to and ask you guys just briefly. Why should people attend Vision UK, and what innovations are you going to have on your stand? So sorry, probably should ask somebody that one. Let's go to Scott again.
So we're going to be at the show. You should definitely come by and say hello. I'm going to be presenting, so if you've got some time, please come along and have a watch. We are going to have some examples of our laser sources on the stand, and we're going to have examples of different detector systems. We also have some components that are implemented into manufacturing setups like amplifiers. So there's quite a wide range of different things on the tabletop. So you should definitely stop by and have a look and a chat.
Brilliant. Thank you, Scott. Stuart?
Yes, we're going to have a full suite of machine vision technologies there, ranging from simplified 2D, AI, simple 3D using time of flight, and high-end 3D using laser triangulation, all running with our Nova software. So a singular look and feel of software. We'll also have our integrated robot guidance solutions there as well. So making sure that, an area of automation we haven't covered in here, but is a very strong area of automation is, do you have a robot? How does it find the next thing to pick up? So yeah, we'll have several demonstrations on the stand. We'll have several people from the SICK organization in the UK, salespeople and industry specialists to talk to. So yeah, feel free to come by and say hello.
Thank you. Simon?
Yes, I would say, the show, if you haven't been for a little while, is very, very different to the original format MVC show that we originally had, which was a one-day show. This is now over 2 days. It's much larger because we were hooked up with the Robotics Bara Association. So it means that there's a lot of cross-pollination because robotics and vision are very well connected. So it means that there's a lot more to see. You know, if you think it's actually, you know, it's grown and grown, it's you know, hopefully going to continue to grow. As far as we're concerned, the stands are bigger. There's another sort of difference. So rather than the original format of a 2x2 meter stand, we've now the minimum really is a 4x4 meter stand. So everything's bigger, which is a great thing as far as what we can demonstrate. We're us in particular. We've hooked up recently with the TKH group vision group, so it means we've got some very new products from them alongside lots of other 3D stuff. I mean, our speciality, a lot of it is 3D. Stuart's already mentioned a couple of bits. There'll be a fringe pattern projection camera on display, color, with moving parts. So it's actually quite a unique camera that, and there's some new software come out without some meshing software and so on. So there's some, you know, we will probably even have some beer on the stand. If that's a reason for somebody to come along, please come along for that reason. As far as we'll be inspecting different types of beer cans and bottles and so on. I'll also be giving a presentation as well on the embedded stuff that we just mentioned. So yeah, there's lots to come and see. If you haven't been for a while, please, yeah, come along.
Right, thank you. And Jack, what are you guys bringing?
Yeah, so as I mentioned, we're a lighting company. We'll have quite a few lighting displays, also like live vision displays with various cameras. And yeah, what TPL does, we focus mainly on having quite versatile lighting, as I've spoken about quite a bit on this call, getting the fundamentals right. So making sure the direction of light is correct, making sure the brightness of the light is suitable for the application, and yeah, ensuring that you spec the light correctly is our focus. And to help customers with that, we have a massive range of flexible lighting products, and we'll have all of these on display, showing customers, let customers get a feel of the products, and yeah, and really looking forward to meeting some people at the show.
Cool, thank you very much. So before we jump into the questions we've got, and we haven't got a lot of time left, I'd just like to say we will follow up with an email with links for you to register to the show. So please come along and see us. We'll also have a feedback email that will come out to you. Please please fill it in and send it back to us. It's really important to understand what you think of these forums that we run. And if you have any specific questions for the panelists, please also put them in there. There'll be a space for you to ask any specific questions you have that you haven't had a chance to ask today. But can we just ask that you put your email address in, and then we can put you in contact with each other and you guys can talk to your heart's content. So questions. So we have a sort of a statement / question from Claire here. She said it's really refreshing to hear about AI, and she says AI needs us to overlap two things: what AI can do, and how valuable it is to the business, what data that I have, and somewhere in the middle, like a Venn diagram, is a start of what could be good for an AI prospect. I mean, just quickly, guys, you probably all agree with that, but have you got any more comments on AI and what we should be considering? Because I think it's a topic that we need to talk about more specifically within the operational technology area and the shop floor, and take it from creative and admin and clerical. It's all very good, it works great there, but what does it actually do for machines, for us? Please jump in.
Yeah, I think from a traditional machine vision point of view, when you've got an application, you employ a machine vision specialist who knows how to do traditional algorithms. You tell them what the problem is and what you're trying to find, and they then put together a system that does that. With AI, it seems to be putting a lot of onus back on the customer to be able to classify what is good and what is bad. So, you know, from a spec sheet, a customer can say, here's the spec, here's the data sheet of what I want it to do, here's the drawing, etc., etc. You need to find this, this, and this. when you're doing it in an AI environment, you're turning to the customer and saying, here is 1,000 images. You have to tell me which ones of these are good and which ones are bad. So it takes the onus away from the integrator back onto the customer, and the customer then has to know exactly what they're trying to achieve from that application. So I find that, there's understanding that this is the process going forward for an AI application, I think will be very difficult to get across to the end customer. You mean to say you're employing me to make a decision on what you are to do? It's a difficult process to go through.
And we all know that it's hard to get a good URS from a customer anyway. So putting more back onto them to tell us what's good and bad is, going to make it difficult. Has anybody else got anything to add?
Yeah, I think that the question is, should we use AI for this application or not? I think that's the first question. That's probably what Claire's kind of getting at with this Venn diagram. A certain part of AI might be really good for the application, but actually it might still be a better approach to use a conventional rule-based approach to solve the problem, because it really depends on what it is. So to go back on what Stuart's saying, one of the big advantages of AI, if AI is going to be the tick the box to say it's the approach to use, is this anomaly detection, i.e. the classification using golden samples only, good samples only. Because what that means is, if you train a load of good samples, anything other than that is bad. Right, so it means if you've got a defect that you have never seen before, for example, you don't know quite what might be the next defect, anomaly detection is almost termed as the holy grail, so to speak, because this is what I want. If it's not that, it's a failure. So problem is that it's so difficult to define that model to encompass everything you want, but actually be finite enough that it catches anything that you don't want is really, really tough. Which is what Stuart's saying about, the so-called labeled, where you have good and bad samples that you give to sort of classify things into different classes. So it's too difficult to answer right now for Claire, but I would say that there's lots of deep learning and AI used in all sorts of tools, things like OCR, optical character recognition. Lots of classifiers are built using that underneath. So lots of cameras, especially smart cameras, will say powered by AI. Well, certain tools might be, but it's actually the bigger picture that we've kind of been discussing here. So don't get caught out. I think AI is brilliant for many, many things. It's very likely that we're doing any application now, there'll be an element of AI in it for sure. Question is, how big's that element?
No, thank you. Jack, Scott, have you got anything to add?
No, I totally agree with what Simon and Stuart are saying. I think it's the AI stuff is, I do believe that it's sort of misunderstood from the outside, but in reality, there's a lot of aspects of the machine vision application that are overlooked as a result. And but I see it as a good opportunity. It puts a bit of the spotlight on the machine vision market. Of course, it comes also from the self-driving car market. A lot of people associate the machine vision market closely with this, and the way that they understand machine vision, it's not really the same thing.
Yeah, I think it's just probably just interesting to consider what point we are on this sort of Gartner hype cycle with this. Jack mentioned self-driving car industry. When I used to sell components for LiDAR systems, there was all these forecasts of volumes for 2022, 23, and then 5-year forecast, and then we're still waiting for a full rollout of self-driving cars. I think it's definitely AI is a very useful tool, but it's not exactly. It depends on how you use it. It's not something that it's like a silver bullet that's just going to automatically fix your setup. You need to sort of work with it. But if you can understand what data you're getting out, then it's definitely going to improve your process for sure.
Yeah, cool. Yeah, we've all been on those this time next year, Rodney jobs.
Yeah.
Come off.
Yeah.
So no, thank you for that. What we do, because we're actually out of time now, so I'd just like to wrap it up. So thank you ever so much to the panelists, and thank you to everyone who's joined us here today. And yeah, as we said, please register and come along to Vision UK. It's a great show, and you'll get to see all of our panelists, and I'll be there as well as a lot of other people from Automate. So thank you very much, and have a great day, and we'll see you on. Thank you. Bye-bye.
Cheers, mate.
Thanks.
Thank
See
you.
you later.